Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Chakwani from Department of Computer Science, Arabic College, University of Delhi. So in this series of database management system, today's topic is about designing a database. So what are we going to cover in this lecture is all about what is actually data modeling, what are its purposes, what is the relationship between various entities, how they are refined, and basically how to go with a database design process. So actually it is not like that we thought of having a database and just we start SQL and insert or create table command we have started. It is not like that. A proper planning has to be kind of we can say done before going into the actual implementation of databases. So that process is actually we can call it as database modeling. So that database modeling, which is all about the whole design and implementation, we need to learn today how this database modeling is done, what are the various symbols, what are the various steps, do's and don'ts, and so on and so forth. So basically we can say we are going to take on with how to design a database and what are the phases in it. So if we can see, there can be designing a particular database is going to involve various of we can say phases. One is kind of we can say the first is initial phase, in which we are going to characterize fully the data needs of the prospective database user. So that means you need to as a database administrator or even a database administrator need to sit with the users of the database, and they need to figure out what are the needs of those users who are going to use the database. Then we need to choose a particular data model. Which data model I am talking about, that I will be taking in a short while. And then after applying the concept of particular data modeling implementation thing, that needs to be translated into the conceptual schema of the database, and then only we will be having a complete picture of the database, that what actually is required. So when we are going to have a fully developed conceptual schema, that is going to indicate or that is going to represent, we can say, the functional requirements of that particular enterprise. So for example, let us say I am going to design a database for a college. Then in a particular college, who all are going to be the users of the database? For example, it is the students who are going to access the database of courses and instructors and so on and so forth. Also there is administration departments, also there is department of accounts, which is going to take care of all the accounts and finance related things. Then there are obviously teachers who are going to who are the instructors for various particular papers. So in order to we can say visualize all these users and the need of all these users for the database, then after this visualization, the modeling concept is to be applied upon these needs, and after the application of the modeling concept, the requirement of all these users are going to be translated, are going to be transformed into a conceptual schema and the fully developed schema. So let us say for example we need to have x number of tables in this particular database, then how many tables will be related with what all tables, and how these are related. So after having this fully developed conceptual schema, we will be saying that we are having the functional requirement of the whole enterprise, that means of the whole college, and that functional requirement which will also give an idea about the operations or transactions that are going to be performed on that particular data. So now finally we have this conceptual schema, and this conceptual schema has to be kind of moved onto the database, which again consist of we can say two phases. One is the logical design and another one is the physical design. So basically we have initial phase, then we have a phase of kind of modeling phase, then we have a final phase, in which in this final phase this abstract data model is going to be kind of we can say translated into the implementation of the database, implementation of the total database. And here in this final phase we have two kind of say we can say terms. One is logical design, another one is we can say is a physical design. So logical design, when we talk about, is deciding on the whole schema, that is the database design requires finally a good collection of relational tables and their relationships and entities and so on and so forth. So that so called good or good enough collection of relational schema we need to see. What all attributes are we going to record in this database is going to be kind of a business decision, what all information is going to be represented, while here we will be involving a computer science decision in terms that what relational schemas should we have and how these attributes be distributed among the various relational schemas. So what relationship various tables in this schema are going to have. Then after having this whole conceptual or kind of we can say a complete schema, we also need to decide on the physical layout of the database. So that process deciding on the physical layout of the database is actually concerned with the physical design. Now, as I have told you in the starting of the lecture, that we are also going to see what are kind of do's and don'ts while we are going to design a particular database. So while designing a database schema, or we can say while designing a database, there are some kind of we can say points that must be ensured or that must be taken care of. So two things to be avoided completely, I can say yes completely or in a major way. One is redundancy. Redundancy is actually what? Redundancy is kind of a repeat of an information. So a bad design may result in the repeat information, and what kind of we can say effect it is going to have on the various transaction or on the database itself is that may lead to inconsistency. Now let me give you an example here. For example, my database design is having the information of the instructor, what information, the ID of the instructor, the name of the instructor, the address, maybe the phone number also, in two of the relations. So this is first of all, this is a redundancy, this is a wastage of the storage. And now let us say what happens in one situation, the address of a particular instructor has been changed, he or she has moved from one place to another. And what will happen, this address one has changed at one particular we can say in one particular table, but forgot to change it in the another table. So that means now the data is inconsistent. Table 1 is saying something about the address of that particular instructor, while another table is saying some other thing about the we can say address of that particular instructor. So that is what you call a bad design, because it is resulting in the repetition of information, and this information may lead to data inconsistency among the various copies of information. So two copies of particular information, there are high chances that this is going to lead to an inconsistent state of a database. Also we need to avoid the incompleteness. On the one hand, we need to avoid the redundancy, that means the data should not be repeated at various places. The other thing which is needed to be avoided is incompleteness, because a bad design may make certain aspect of enterprise difficult or impossible to model. That type of situations, that type of circumstances should be avoided, and whatever the requirement, whatever the aspects of the enterprise are there, those all should be modeled within a database. Now, is it already is it only which is kind of avoiding the bad design? So, what I am trying to say here is only avoiding the bad design is not enough. There can be various alternatives among the good designs. Among those, one must be chosen, or maybe we can say various alternatives of the designs are available, and among those alternatives we must choose the the best available one. Now, when we talk about the first phase of the design, that is trying to understand the requirement of the prospective users, that is one thing in which database administrator need to sit with the prospective users of the database and try to figure out their requirements or expectation from the database. Another thing, or another we can say step, was about the data modeling. So, when we talk about data modeling, the first term which comes into the approach is entity relationship model, and that is the that is the thing which we will be carrying out from here in a kind of huge level of detail. And another one is about the normalization theory, and normalization theory we will be taking into some other we will be covering in some other lecture. So, two design approaches we have here. One is an entity relationship model and another one is the normalization theory. So, let us focus on entity relationship model. So, entity relationship model says the whole enterprise has to be modeled as the collection of entities and the relationship. Now, let us try to understand these two terms. One is entity and another one is the relationship. That is how the a complete enterprise can be represented, can be modeled as the collection of entities and relationships. So, let us try to understand first of all the meaning of these two terms. So, when we say entity, entity is something, we can say, a particular object or a particular thing that exists, and it is also distinguishable from we can say another entity. So, that is what you call entity, and it is also having some we can say attributes or some properties. So, for example, let us say we have a student entity. So, that student entity or a particular student can be is distinguishable from other students, and each and every student is having some set of attributes. Now, what kind of set of attributes I am talking about? In case of a student, these attributes could be roll number, then the name, and then the course in which the student is enrolled, what papers he or she is taking, what is his admission, his or her admission year, and so on and so forth. So, yes, this entity which is actually something that exists, it is kind of we can say distinguishable, or it is described by the set of attributes. Now, there will be kind of we can say various there are various relationships, or there are various associations among several entities. So, for example, let us say we take one entity as an instructor and another entities as students. So, instructors are designated advisors for various students. So, the relationship between instructor and the instructor and the student entity is about the that association which is instructor. So, instructor here is the relationship. Now, this whole entity relationship diagram has to be modeled first, and then this has to be translated into a pictorial diagram. So when we talk about this modeling of entity relationship diagram, this is actually done in order to facilitate the database design by allowing the specification of an enterprise schema that represents the overall logical structure of the database. To cut it short and make it simple, we can say overall logical structure of the database is schema, and the kind of we can say your database design is to be developed by allowing these specification of the enterprise schema with the help of ER model. So ER model is something which is going to, we can say, which is going to make your overall logical structure of the database or schema of the database in a we can say in a concrete form. So the ER data model is going to employ three types of basic concepts which I have already told you. One is entity set that we have seen. Then we have the relationship sets, and I have just explained this relationship with the help of the term instructor or the relationship instructor, which exists between the entity student and the entity teacher or faculty, we can say, and each and every entity is described with the help of various properties of it, which are more commonly known as attributes. Now this ER model is having, as I was telling you, that this is having a diagrammatic representation also, which is going to depict, or which is going to show the logical structure of a database graphically. So to sum up this entity relationship diagram, or ERD in short, we can say it is actually a data modeling technique which is used in more specifically used in software engineering, and this is used to produce, or this is used to generate a conceptual data model of an information system. So often any information system or often any enterprise system, if you want to model it conceptually, ER diagram is the tool which is going to give you a particular, we can say this logical structure of the complete database graphically. So basically your ER diagram is going to illustrate the logical structure of the database. Now this whole process of data modeling, actually if we can see, revolves around taking, or knowing about or discovering the organizational data requirements and the requirements of users of that particular database. So these requirements are actually based on various policies we can have. They can have meetings amongst themselves. They are having some set procedures, some system specifications, etc. So these requirements are going to come up from their whole environment, be it policies, be it some meetings, be it some procedures or system specifications. Now database administrator from all these requirements need to see that what data is to be modeled, what data is important, what data is to be modeled, and also need to identify that how are we going to maintain that particular data. So in order to in order to identify and in order to understand what data is important, this activity we can say involves the construction of your ER diagram. Now what is this major activity of this phase is about what are the entities, what are going to be its attributes, what are the relationships between these entities. So it is about we can say identification of entities, attributes, and their relationships. So coming to the graphical representation of an entity, or we can say entity relationship diagram, we have three basic building blocks of an ERD. So first one is the entity, second one is the attribute, and third one is the relationship. Now using what all symbols these building blocks are going to be represented, let us see that. So in order to represent an entity, we need to have a table, or we can say that entity is being represented with the help of a table. All the attributes which belong to that particular entity will be columns or fields within that table, and whenever there is a line between the two tables, or we can say kind of between the three tables, if it is a kind of ternary relationship, then that line is kind of we can say representing the relationship. So in order to represent the entity, we use table. In order to represent the attribute, there are columns within that particular table, and using a line we are going to represent the relationship. Now when we talk about entity is a table and attributes are the column, but here when we talk about entity relationship diagram, this entity relationship diagram is not going to represent this entity with the help of a table, rather than it is going to represent the entity with the help of a rectangular box. A plain rectangular box will be there in which the name of that particular entity, for example student, is there, and then there are we have various columns into that. For example, here you can see we have student ID, we have last name, and we have first name. So three columns. So basically what I can say here, this entity student, it's having three attributes. One first attribute is student ID, the second attribute is the last name, and the third attribute is the first name. So whatever are the we can say columns of that particular table, those columns will become the attributes of the entity, or going in a forward direction or going in a right direction, if we can say, we need to design the entity relationship diagram first, and then we will start kind of implementation of that particular database, or actual we can say coding of that particular database, actual conceptualization of that database. But before that, that ER diagram has to be we can say made. So in an ER diagram, this entity student will be represented with the help of a rectangular box in which all the attributes, here in case of this student entity, only three attributes, all the attributes are actually written, names of all attributes are written in that particular we can say rectangular box. So in this way we are going to represent an entity when we talk about an entity relationship diagram. Also if we need to see that what is actually, as I have told you, that entity is an object or a concept. This can be a strong entity or this can be a weak entity. More on the types of entities in in a short while. And the diagrammatic notation which I was talking about is the rectangular box. So for example, we have a particular student, a particular company, or an event or a plant. So an entity is, as I have told you, is an object that exists and is distinguishable from other objects. So one student is something that exists and is distinguishable from other students, because it is having its unique roll number or enrollment number or something of that sort. Now when we talk about entity set, that means a set of entities of the same type that share the same property. So for example, set of all students. So set of all students is actually an entity set, or set of all persons, or set of all companies, where company is actual and we can say individual entity, while the set of companies is an entity set, and each and every entity is represented by these descriptive properties that they are going to possess, and these are nothing but attributes. So, for example, let us say we have instructor, which is an entity, and that instructor is having 3 attributes or is distinguishable with the help of these 3 attributes. One is ID, another one is name, and third one is salary. Similarly, for the entity course, we have course ID, we have title, and we have credits. So, we have entity and then we have attributes, and now among these attributes we also need to see which is the primary key of that entity set. That means a particular key or a particular field which is present there, so that these entities can be recognized or can be distinguished from one another. So, you all understand what I am trying to say with the help of primary key when I am talking about primary key as an attribute which is there to find the unique or find the we can say find the find the feature which is going to distinguish from one particular entity to which is going to distinguish one particular entity from another one within an entity set. So, in entity set of a student, how student 1 and how student number 9 are distinguishable, that is basically because they have their own specific IDs, even if their names are same. So, basically your ID or the student ID or roll number is something which is going to uniquely identify each member of the set, and that is what the primary key of the set or primary key of the entity set is. So, in case of an instructor, we have ID, name, and salary. So, ID, name, and salary, the obvious candidate for here for being a primary key is the instructor ID or the ID only, while in case of the course we have that course ID, title, and credits. So, an obvious candidate for this we can say primary key in case of the course entity is going to be the course ID. Now, the question comes up, how are we going to find the entities? Now, these entities, as I have told you, that these are objects which can be which exist and can be distinguished from one another. So, anything, whether it is a tangible concept like a customer or a product, or an intangible concept like it is an order or some account receivable, all these anything like people, places, objects, events for which we are going to store the information, that is going to be an entity. And here, as I have shown you earlier as well, we have an entity student in this entity set. So, this whole table is actually an entity set which you can see on the screen. This entity set is actually having 6 instances. Each row here is termed as an instance of the entity set, or each row here we can say is an entity. So, student here is an entity with the features or with the attributes student ID, last name, and first name. So, one is the student ID 2144, another one the last name for which is Arnold, and the first name is Betty. So, this itself make as one itself qualify as one entity, all these 3 fields together. And this is also, you all understand that this is also known as entity instance. A single occurrence of an entity is entity instance, and in this particular table I can say there are 6 instances. Now, as I have told you that how are we going to represent these entity sets in entity diagram with the help of rectangles, and then we will write the attributes inside and underline the primary key attributes. That we will see in detail in our upcoming lectures. So, here in this lecture we have tried to understand that what are how to design a particular database, what are the phase in designing of that database, and we have started going into the details of the data modeling phase, in which we are drilling down into the concept of entity relationship diagrams. And here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. Thank you for a patient hearing.